Welcome back. All right, so right away I stopped the tape. I didn't want to do the whole tape over again. I already did 20 minutes of tape. But something was clearly wrong because the answer could not be negative 10/3 and it could not be 25. All right, so if we think about our feasible domain, I'll put it right here. Just come on. There we go. Feasible domain. We know that x has, first of all, has got to be greater than 0, right? It can't be negative. Can't cut out a negative amount. How would you do that? But we know that it has to be less than, can't even be 25, right? It actually has to be less than 12.5. Otherwise, 2 times 12.5 gives me 25, and I will have cut the entire side off the piece of paper, right? So we know it's got to be in between that range, and what we got was utter nonsense. And that's because I had a cite sign error. There was nothing wrong in the work I was doing, but I did not write down the two numbers have to multiply to give me 750. Notice that's a positive number and add to give me negative 65. If that had been negative 750, then yes, the correct numbers would have been negative 75 and 10. But that's a positive 750, which means I need two negative numbers. Negative 50 times negative, was it 15? I think it was 15. Negative 15, yes, negative 15. Negative 50 times negative 15 multiply to give me 750. And negative 50 plus negative 15 add to give us negative 65. So we had a simple little factoring here. All right, so let's fix that. 0 equals 3x squared, I'm going to put the 15x with you, minus 15x. And now, such a simple little thing, you know. Should have caught that. I need two negatives. All I had to do was think about that, and I wouldn't have made that little mistake. And I went for the simplest one. Simplest pair of numbers that multiply to give me 75, multiply to give me 750, and add to give me 65. Unfortunately, they multiplied to give me negative 750. So 3x squared minus 15x plus negative 50x plus 250. Our group, our greatest common factor here is a 3x, and that would be an x minus 5. And then we can pull out a negative 50, and that would be an x minus 5. So we have 0 equals 3x minus 50 times x minus 5. So they'll both be positive numbers. They at least meet that. All right, and so let's solve the rest of that. So this one would be x equals 50 thirds. I'm kind of running out of space here, right? So you'd have 3x minus 50 equals 0, 3x equals 50, x equals 50 thirds, x equals 5. Right? So they're both positive numbers. Right? But 50 thirds is greater than 12.5. You would have cut off more than half the sheet of paper. How do you cut off more than half a sheet of paper twice? Right? It just wouldn't be possible. Right? So this problem, this one here is, oops, I need a teeny bit more space. Not that much space. No, I think you can still see. Not in the feasible domain. But this one is good. All right, this is the critical point. I'm going to fix the screen a little so it's not this big. All right. Whoops. Recording box is in the way. I can't change back. There we go. All right. No! Stop! All right, so there we are. All right, so we have our critical point x equals 50. All right, and so let's continue. And we can continue right here, and then we'll switch over to the other page. All right, we'll just make a little box around that. And step 5 is going to be to take the second derivative and plug in our critical point. All right, so that would be our first derivative was right there is dv dx equals 1,000 minus 260x plus 12x squared. All right, and if we take the derivative, d2v dx2. All right, so derivative of 1,000 is 0. Derivative of negative 260x is negative 260. And the derivative of 12x squared would be 24x. All right, so we'll set that one equal, we'll plug in our critical point. We're not looking for anything else. We're going to plug in the critical point and evaluate. So this was 5. So that would give us negative 260 plus 24 times 5. All right, so 24 times 5, that's going to be 120. So this would be negative 140. All right, so we'll interpret over here. We'll do step 7 over there, and then we'll finish off, or step 6, however I numbered them this time. And then we'll finish this off by answering the question. So number 6, so since f double prime of x is less than 0, oops, and I'm sorry, I should have had f double prime 5. F double prime 5 is less than 0, then x equals 5 is a relative maximum. All right, notice our function here, if we were to graph it, would have been concave down at that point. All right, so now we just need to answer the question. All right, and I'm going to just take this question over to the next page. We have, oops, if it'll let me. All right, I'm going to walk over to the computer. I'm going to cut and paste it there, and we'll answer the question. And oops, I need to put in a page. And by the way, I blame my error on the fact that I haven't eaten lunch yet and I'm hungry. Yeah, I'm just not myself when I'm hungry. All right, so we found x. X was 5. Right, and if you remember, we had a equation, and that was volume equals, it was 1,000 minus 130x plus x squared plus 4x cubed. That one right there. All right, so volume was 1,000. Oh, actually, we did answer the question. Find the size of the corner which produces a container that holds the most soup. We don't have to do anything more. What am I doing? We don't need to find the volume. We're done. So we've answered it. So the answer to the question is x equals 5 is the size of corner for the largest container. Once we solved for x, we did everything we needed to. We'll box that into. All right, that's it. So hopefully my little boxes were easy enough to follow. I think it's organizing my work a little bit, keeping me contained there. But we got solving a little, take off a little space there. But I think you can read that. And this is a new question. So I'm going to end this podcast now that we have solved it. Yay, and we'll come back to this one. All right, bye for now.